So here we are starting chapter 5, and we're going to talk about ratios, rates, and proportions. So the term ratio means that is a quotient. A quotient means a division problem. So there's a numerator and denominator. So a ratio is a quotient, and you can never divide by 0. That is going to give us a comparison between the number in the numerator and the number in the denominator. So every fraction is a division problem, and every fraction is going to represent a ratio. So we would, if we had the fraction 3/7, in geometry we would read that as 3 to 7. It's in the ratio 3 to 7. Sometimes you would also write it 3 to 7. So those are 3 ways to write a ratio, and often we'll want to put our ratio in lowest terms, just also the way we would put a fraction in lowest terms. So if I had a ratio 4 to 8, I'd probably want to write that as the ratio 1 to 2, or 1 to 2, or 1 to 2. All of those are equivalent, but you do like to reduce your ratios if possible. Now the thing about ratios is that there can be units in the numerator and denominator, but they should have the same units so that eventually the units would cancel. Or it has to be at least the same type of units. So you might have inches, feet, and yards, and those would all cancel with each other. Or you might have minutes, seconds, hours, those would all cancel each other. So the units must be commensurable. In other words, being able to be converted to the same unit of measure, a measure of time, or a measure of distance, or a measure of area, a measure of dollars. So when you're simplifying a ratio with 2 quantities, you eliminate the common unit. So it's like taking the unit out of the numerator and the denominator. And if 2 quantities do not share the same unit of measure, they are incommensurable. So let's practice here. They want us to find the simplified form of each unit. So, of each ratio. So A, that's going to be 12 to 20. And if I want to reduce that, let's divide both the numerator and denominator by 4. That would be 3 to 5. How about B? That's 12 inches to 24 inches. So here they have the same units, so we're going to just cancel out the units in the numerator and denominator. And 12 goes into 12 once, 12 goes into 24 twice. So B could be represented as the ratio 1 to 2. All right, how about C? We have 12 inches in the numerator and 3 feet in the denominator. Now they're both units of distance, so they are commensurate or commensurable. We're going to put them all in inches. So 12 inches in the numerator, and we're going to write this denominator, since there are 12 inches in a foot, this is going to be 36 inches. And see, the inches will cancel. 12 goes into 12 once, 12 goes into 36 3 times. So that would be represented as the ratio 1 to 3. Okay, how about D? We'll go ahead and put D over here. 5 pounds to 20 ounces. All right, so they're both units of weight. And here we see that there are 16 ounces in a pound. So this is like, instead of 1 pound, this is going to be 15 times 16. We're going to change this to ounces. So rather than 1 pound, we're going to have 16 ounces. Over 20 ounces. And our ounces are going to cancel. And 5 times 16 is 800. No, that's 5 times 16. That's 80. All right, let's let's put a little pause here.